right, let me go over each of the review problems one by one and see if you guys have any questions along the way, okay? So, okay, so number one says describe the transformations that change the graph of the first function. So we have all these things that's occurring, right? There's a new a value, there's a minus, there's a new b value, there's a c, there's a d. So we have a lot of things going on here. Let's go ahead and just get as much information as we can. Well, before we do that, though, we have to rearrange this equation, right? This equation is not quite showing our true c value. So I know my a is -2. What's the b value? 1/4. Okay, and I don't see it outside a set of parentheses. That's going to throw off how I interpret the phase shift here. So I'm going to rewrite the equation. Y equals, get that bracket to show up. Okay, we have to ask ourselves, 1/4 times what will give me 3 pi? 12 pi, right? And if you're unsure about that, just try different numbers and convince ourselves by distributing through, right? We should be able to get back to the starting point just by distributing that 1/4 through. So 1/4 times theta is theta over 4. That makes sense. 1/4 times 12 pi is 12 pi over 4. That's reduced to be 3 pi. So we know we're good, right? We know that we've factored out correctly. We've identified the correct new c value, and then the -5. Okay, so a couple of things I think is easy to spot is that negative. We know the negative is going to be a reflection over the x-axis. And out there. The 2 is going to be a vertical stretch by a factor of 2. That 1/4 is a little bit harder maybe to interpret, but let's find the period and let's compare it with the old period, the parent period, and see if we can convince ourselves what's happening with our horizontal stretch or compression. Yes? Yeah. What I did was I asked myself 1/4 times what will give me 3 pi. So I had to go through this little puzzle here. And I got to play with different numbers to see what's going to make that true, right? And it's the only way I can get that to be 3 is if it's a large enough number where it will cancel out to be 3 and a pi. So it has to be 12 pi. Okay, so let's find our new period based off of the b value. Two pi divided by 1/4. Dividing by a fraction is the same thing as multiplying by the reciprocal. So this tells us something, right? If our original period is 2 pi, but now all of a sudden our new period is 8 pi, that's stretching, right? It's taking what initially was 2 pi, but now it's taking 4 times as long for it to complete that cycle. So we know that there's a horizontal stretch by a factor of 4 because we're comparing the old with the new. Right. The 12 pi is going to tell us there's going to be a shift left by 12 pi units. The -5 is going to tell us it's going to shift down by 5 units. Reflection, vertical stretch by a factor of 2, and a horizontal stretch by a factor of 4. Okay. All right. Any questions? Yes. Because whenever we have reflection, it's always going to be over the x-axis. I mean, there technically there could be reflection over the y-axis, but that's only if a negative shows up inside the parentheses. But we won't deal with it. We're only dealing with a negative outside, in front of the a. Because the 8 pi is 4 times longer than 2 pi. Because it's stretching from 2 pi to 8 pi, so that's 4 times as long. Because 2 pi times 4 is 8 pi. Okay, number 2. Write a cosine function with amplitude 2, reflection over the x-axis, period is 2 pi over 3, phase shift left pi over 2, vertical shift of 12 units. This is more straightforward, right? This one, we take the period, we go through the formula, equals 2 pi over b, we solve for b. Once you have the b value, then you're just plugging into the formula, right? This is a very familiar problem for us, I think, for number 2. Okay, so the formula is period equals 2 pi over b. 2 pi over 3 is a period. I'm trying to work backwards to solve for b. Cross multiply, 2 pi b equals 6 pi. Divide both sides by 2 pi. 6 pi over 2 pi is 3, so my b value is 3. Reflection over the x-axis, I know that's going to give me a value of -2. Phase shift to the left, pi over 2, I know that's going to be a plus pi over 2. And then vertical shift up 12 units, so I know it's going to be a plus 12. Just insert everything, A, B, C, D, into the right spaces. Any questions? Okay, number 3. Does anybody still need to look at number 2? Okay, write a sine function that completes 1/4 of its period in 3 pi. Okay. You kind of have to figure this out a little bit. What does this mean? Can you guys give me another way of saying this? What does that mean? Okay. But what does this tell us about the full period of this sine function? Good. So that means 1/4 means 1/4, right? So that means after 1/4 of the sine function, it's only going to cover, it's going to cover 3 pi. But we got to do that a couple more times, right? So by the time that it gets to 3 pi, it's only 1/4 of the way through the cycle. So exactly like you said, we got to multiply that by 4, right? So that means we got to go through 3 pi, 3 pi, 3 pi, and 3 pi. All that's got to occur in order for a full cycle to exist, which means my period is really what? 4 pi. Okay, we'll work backwards to solve for the b value. And then the shift right, we know it's the c value. Now this, we did this a little bit on Friday where we kind of have to draw the graph, right? Get that minimum, get that maximum, and then draw the dotted line, and that will tell us where the d value is. We can figure out the a by measuring the distance. Okay, but I'm gonna finish this part first. Period equals 12 pi. I can work backwards to find my b value. Okay, b value is 1/6. All right, here's my graph. I'm not going to draw the entire graph, but I just want to at least have some way of counting here. Minimum value of -7 and the maximum value of 3. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. So we may have to do a little bit of guess and check here, but do you guys know where's the center of my graph so that it's the same distance above and below? Okay, let's try -2 here. So if this is the true center, I should be able to count up to my max and count down to the min, and I should be this covering the same distance here. So from -2 here, 1, 2, 3, 4, 5. Distance of 5. Let me count down here. 1, 2, 3, 4, 5. Okay, so that's consistent, right? We know what our A value is, and we know what our D value is. It doesn't specify if there's a reflection. You can say plus or minus 5. It doesn't matter. Either one works. Any question with number 3?
Was you considered wrong? I didn't put the minus.
No. Either one. I just want to show you the options. You can say -5 or +5. Either one works. Okay, number 4 is more straightforward. We've been practicing through these problems a lot, right? Just gathering all the information and then graphing it. But we got to rewrite this, right? This is not in the correct form. Okay, we have to ask ourselves 3 times what will give me 3 pi over 4? Just pi over 4, right? 3 times pi over 4 gives us 3 pi over 4. We know that works. Remember, your amplitude is always positive, okay? Okay, now that C value is telling us how the phase shift is occurring. Plus means left. Vertical shift. Domain is always all real numbers, but the range, we have to wait. Range, we don't know until we sketch the graph and actually can see where the max and mins are, right? Let's create our chart here. So I'm just incrementing by 1/6. So 0 plus 1/6 is 1/6, 2/6, 3/6, and 4/6. There's an impact with the shift left. Find some common denominator. Well, this one is easy here. No common denominator needed. Here I have common denominator of 12. So 2 12s minus 3 12s is negative 1 12. Cosine starts at the max, multiplied by -3. Okay, thank you. My new middle is a -1. So I'm going to use that to help me count from the center. Let me count down 3 units. Takes me to -4. My 0 is the dotted line. Up 3 units. Dotted line. I'm sorry. Nothing at 0. Forgot about 0 is not a one of our points here. So power over 12 should be at 3. Any? Yes, there should be 5 points. 1, 2, 3, 4, 5. Don't include the y-axis. Y-axis is not going to be one of your points. Oh, right. On the quiz, I'm only going to ask you for 1 period.
Not having trouble like.
Yeah, got it. I understand. Too much going on. Just 1 period is enough. Okay. I got a handout there if you want to pick one up. Okay, let's go to, does anybody still need to, any questions about number 4? Okay, look at number 5. Really, for number 5, you just have to worry about your A and your D value. It's only asking for your domain and range, so all you need is to figure out where your D value is and how far to move above and below to get to your max and mins. Are you good with 4? Okay, number 5. Yeah.
It's the value. If it's being like subtracted in the equation, does that mean you're moving left or right?
Opposite. You're always doing opposite if it's inside the parentheses. So negative is right, positive is left. But your D value, your last number, that's
not for C value.
Right. C value is opposite.
So like if I was subtracting, the graph would go forward. Like
We'll go to the right. Okay, let's look at now 5. It's only asking for domain and range, so we know the domain is already all real numbers. Don't have to worry about that. It's the range is vertical. It's only going to be affected by your A and your D value. So we really don't care about the phase shift. It's not going to have an impact on us, so we can save our time by just not worrying about that. Okay, your D value is negative 2.5, so let's go ahead and mark that off. So here's negative 2.5. If my D value is negative 2.5, I know my A value is 4, so I got to go up and down 4 units, right? So 1, 2, 3, 4. That's going to be a 1.5. And if I go down 4 units from my new center, 1, 2, 3, 4, that's going to be negative 6.5. Okay. Don't have to worry about, I mean, I know my cosine graph is going to look something like this, but we don't have to worry about our sine graph, right? But all I care about is the domain and range, so I just need to find that max and min.
Thank you.
Okay, see you. Thank you. Okay, so does that make sense with number 5? As long as you have your A and D value and draw out your graph, draw out your interval, that should be enough for you to find your range.
One question, you just subtract or add 4 to the.
That's right. Subtract 4 from the D value because you know that your A is always the same distance away from your D value. Right? Any questions with 5? Okay, let's look at number 6. Graph, stated cosine function and sine function that represents the graph below. I'm looking at this, I'm thinking, okay, this looks like a cosine graph. I'm going to go after the cosine graph first. Then I'll worry about the more difficult one with the sine. Okay, I don't quite see a full cycle in front of me, so I'm just going to extend this out so I can kind of get that full cycle to occur. I see my interval is going to be 6 pi, right? So there's a 6 pi here. It's not showing me a 12 pi, but kind of helps me see it. So 1, 2, 3. There's one more increment. Yeah. I just want to kind of see that full cosine graph. Just visually, it helps. So here's my, so I know that's my period, right? There's my period right there. Okay, so from that, I can get to my B value. Okay, my B value is 1/12. What's the A value? 2. The nice thing is the D value is 0, right? So we just have to count up and down from the x-axis. What's our C value? Do we have any shift? No. That's why we picked the cosine first, right? There's no shift. We know it's easier to deal with. And D is also 0. Okay, so. Okay, we purposely targeted the cosine first. It was the easier function to work with. Now the sine function, let's draw a sine function nearby and then get the equation of that sine function, and then we'll worry about the shift after that. So here's my sine function. Okay, let's create this sine function first, and then we'll worry about the shift later. But a lot of things are going to stay the same, right? A is still 2, B is still 1/12. We don't know what our C value is, but we know our D is 0. So now the last, so this is the dotted line, right? This is the dotted graph here. Now, what do I need to do with that dotted graph to make it turn into the graph that I really want? Yeah, I got to shift it to in which direction? Left by 1 tick mark, right? Tick mark is at 6 pi. So it's going to be 6 pi, yeah. Okay.
Can you explain how you got that 6 pi?
Good. So here's my sine graph, right? There's my sine graph. How far would you have to move this dotted line to turn it into this graph in black? There you go. So that's how we know plus 6 pi. Okay, you know it's a full period if it's able to get to the starting point, and then you can imagine it repeating the cycle again. So we know that that's the full cycle because it starts at 0 and it ends at 0. Because after this, it's going to repeat that process again, right? Yeah, I like to draw my sine graph from starting at 0. That way I can see that full picture, and then now I can see, okay, if I just shift this to the left by 1 tick, then I'm able to get that graph to look like the graph in black. So I'm starting with the dotted line, the sine graph, and I'm just shifting it left. And now I have an equation for the same graph. Okay, part B. Okay, again, what's the easier graph to match with? Cosine. Okay. This is a little bit different because we have to get that middle, right? It's not going to be centered at 0 here. Can you spot where the D value is? 2. You can always confirm by counting from the dotted line. It should be the same distance to the peak as well as it is to the valley. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So, well, that tells us our A value, right? So that makes it quick there. To find the B value, we got to find the period first. What's the period of this cosine function? Okay, let's see here. So I'm going to map out the full period here. It's going to go from peak to peak. Okay, there's the period of my cosine function. So I know that Period is b, is pi. Okay, my b value is 2. No shift. And then d is 2 as well. Not reflected, starts at the max, so. Mm-hmm. Mm-hmm. So the way we can take that 3 outside the parentheses is because we have to get that c value to be true. So we ask ourselves.
Would you divide everything by 3?
No, this is what I would do. I would go through this little puzzle here. The puzzle is this. I have to ask myself, because I don't know what this number is yet, right? Got to ask myself, 3 times what will give me 3 pi over 4?
Okay.
So
I guess pi over 4.
exactly pi over 4, yeah.
So you have to do that for each and every. And also, what's the answer to number 1?
Here, let me finish B first, and then I'll go back. I'll show you number 1. Hi. Hmm? Yeah. So let's see. Yeah. So I see you Wednesdays and Thursdays.
They told me Monday and Tuesday, so.
Oh, really?
Yeah.
Yeah. Monday and Tuesday is for some of the sessions, but for me it's Wednesday, Thursday. So I'll see you Wednesday, Thursday. Okay. Thanks. Okay, so we have our cosine. Now we're going to build our sine, right? Let's graph a sine graph that's nearby. So sine graph that's nearby, I got to start at the center, and I'm going to get to my max. So that looks like a sine graph, right? That's a sine graph with a period of pi. Yes.
Why did you go to 2, like pi over 2 as the?
I think my max is at pi over 4, right? Is that what you? Because I know my graph has just shifted a bit, so I know I got to hit that max. Usually, yeah. How did you do it?
Is always at like the max is always at pi over 2, or does it just like vary between?
It depends, right? It always depends on what your interval is, right? Your subinterval is going to help determine, because if the graph is stretched or compressed, then it's going to be a different subinterval.
Okay, so it's always like the first, so it would be pi.
Yeah, for this one. Yeah. Typically, if I ask you this question, it'll be close by, right? Usually be pretty close, either to the left or to the right, by a little bit. Okay, so let's create our sine graph information. Our A value is still 6. Our B value is still 2. The C we don't know yet, and then the D is still going to be 2, right? So this graph, this function is built for this graph that I have, but it looks like it's shifted. I need to move it, right? I need to move it to the left. Yeah. Yeah, you can definitely use your highlighter. I think that helps. Okay. Does anybody still need to look at part B?
Yeah.
Okay, all right. See you in class. I'll turn to the first page again for those who came in late, and I'll go over any questions you want to go over.
I still don't understand the making like so for like this one, why did it go here instead of there? Like I don't understand when you make, because like you have to figure out the sign, so you like make the fake sign graph like this. I just don't get it.
Yeah, this one is a little bit more challenging just because both this is not a sine or cosine graph by itself. They're both needing to be shifted.
Okay.
So with the sine graph, it's easier maybe to spot the sine graph. Oh, gotta have a 0, right? So if I see this, I'm thinking, oh, looks like I can start the sine graph here. So what if I just sketch the sine graph like how, okay, oh, okay, you see how this sine graph is going by 2 subintervals here? So it's jumping 2 tick marks before it hits
before it hits the next. Okay, so
that's why when we shift it, we have to shift it by pi over. Oh, what is that here? This is harder here. Pi over 4. Oh, that's why I shifted by pi over 4. Because, and then so if this is my, let's see. Okay, so if I want to create my sine graph here, I've got to go to here. Got to go to here. So I can do this sine graph by saying this is y equals sine. And then do you find your period for this one? Period is still still 2 pi, right? So I can take that 2 pi there. Or still 1.
So it does just depend how many subintervals it goes from.
And this one, this should be, I need to shift it to, I need to shift this graph to the left by pi over 4. Yeah, this one's a little bit harder.
Oh, I kind of see it there when you did that one. Okay. And then for this one.
This one's easier. I think this one's easier because it starts at -2. Starts at, yeah. So this is nice. This is there's no shift going on. It's already starting how you would expect. And then each tick mark is, let's see, this is power. Oh,
does it go by 6?
Go by 6, right? 1, 2, 3, 4, 5, 6. So yeah, that's why b is equal to.
Okay, so it's by 7.
Yeah. These are a little bit harder.
Okay.
I think these are easier, like ones that you expect. Okay, here's number 1.
Wait, okay, so for these types of questions, when it comes to horizontal stress, you base it based off of 2 pi, and then if it's more, then
it's a stretch.
And
if it's less, then it's going to be compressed.
And then is that the same thing for The vertical?
I think vertical is a little bit easier because vertical, you just look at this number, you can tell. If it's greater than 1, it's going to be stretched by 2 or stretched
And
by,
if
if
it's
it's
not-
less, then it's going to become compressed.
Okay,
I think only this one you got to, I mean, you can look at that number, but it's going to be opposite.
yeah.
So if you see that 4 in the denominator, it's going to be stretched by 4. If you see a 4 in the numerator, it's going to be a compression by 4. But you can also compare it with your new and old periods to convince yourself.
Okay.
I have a question right here. I'm just like really stuck on this and something on the back. So if tangent line is horizontal, do we just pick a value and the y stays the same?
So tangent line is horizontal means where the slope of the graph is 0. So
Okay.
you're going to have to
Look at 0 to the derivative.
you're going to have to set the derivative equal to what?
0. Okay, thank you.
Can you put it over 3 and 4?
Mm-hmm.
Yeah, but like your initial.
Here, I'll give this to you. Here, here you go. Come on.
Okay, so you know here how you said this, it's saying it's one of the intervals. How would you know if you were looking for it to have like in this scenario like it is the interval, but how do you determine if it's not asking you to get intervals off of that number, if that makes sense?
Right. So basically, that problem is trying to help you find a period without telling you what the period is. So it's telling you that after 3 pi, it's only a fourth of the way to its full cycle. So if it's only a fourth of the way, then I need 3 more of these distances.
Okay.
What if I say after 2 pi, it only completed. What about the 2 pi completes 2 cycles?
So then it can only completed the first 2 intervals. It would be pi.
Yeah.
Okay.
So you're using this, it's kind of like a convoluted way to try to see if students understand. Use this knowledge to help you get to the period. Once you get to the period, then just move forward like how you're going.
Okay. Thank you.
And then each one of the quiz is going to be like this too, where each one of the questions covers.